All right, let's take a look at this video. Well, you should have already watched it at the beginning of this. And then so let's draw the curves from the video showing low and high standard deviation. You'll do that part. Let's talk about this one. All right. 68% of men are between what two heights? Okay. Well, answer that from the video. Answer these from the video. And then we will just jump right into the lesson. All right, so let's take a look at our lesson 6.4. Example 1. Scores from the first 6 basketball games are 75, 83, 96, 100, 121, and 125. Calculate the mean. So that means that we need to add okay, so we are going to add and then divide by 1, 2, 3, 4, 5, 6. All right, so from your calculator, we are going to add all these numbers up. 75 plus 83 plus 96 plus 100 plus 121 plus 125 divided by 6 and 100. So the mean equals 100. All right, if the standard deviation is 18, which values are within 1 standard deviation of the mean? All right, so if our mean is right here at 100, and we need to know what 1 standard deviation is away, which is this weird symbol. So this is the plus, and this is the minus. So the standard deviation is 18, so I'm going to add 18. I get 118. I'm also going to minus 18, and that gives me 82. Okay, so which values are within 1 standard deviation of the mean? So that is 82 to 118. All right, so that would be 83, 96, and 100. Okay, so 83, 96, and 100 are within 1 standard deviation of the mean. All right, let's take a look at example 2. 10 friends scored the following marks in their end of the year exam for math. We're going to calculate the mean. So again, we are just going to add them all up and then divide by the total numbers. Okay, so let's go to our calculator. 23 plus 37 plus 45 plus 49 plus 56 plus 63 plus 63 plus 70 plus 72 plus 82. All right, so divided by 10, there are 10 friends. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On my calculator, that gives us a mean of 56. Okay, so we're going to do plus a standard deviation and minus a standard deviation. Okay, so we're going to take the mean or the average in both cases. We're going to add the standard deviation and subtract. So that becomes 56 plus 17 and 56 minus 17. Okay, so we have 56 plus 17, we get 73. And then 56 minus 17, we get 39. So we need numbers not within 73 and 39 because that is 1 standard deviation. Okay, so 73, anything in there. So 82 is the only one, and anything lower than 39, so that's 37 and 23. So 23%, 37%, and 82% are not within 1 standard deviation from the mean. All right, Let's take a look at example 3. God, you people. All right, so let's take a look at example 3. Robert and Andrea both hit 10 golf balls with a mean distance of 300 yards per ball. Robert has a standard deviation of 5, and Andrea has a standard deviation of 15 yards. Who is more likely to hit very close to 300 yards? Okay, use your evidence to support. So 300. So Robert hits between, even though his mean is 300 yards, and we know that in one standard deviation is 68% of his results. So 68% of the time, Robert hits between, Robert is between 295 and 305 yards. Well, if you look at Andrea, 68% of the time, okay, 68% of the time, she is between 285 and 315 yards. So, yeah, her mean is 300, but her spread is a lot further away. So, who's more likely to hit closer? So, let's finish this. So, 68% of the time, Andrea is between 285 and 305 yards. So Robert's results are more clumped together, so he is most likely going to be closer to 300. I'm sorry, that's 285 and 315 yards. So 68% of the time, Robert is between 295 and 305 yards. So he is closer. So Robert will most likely be closer to 300. Okay, Andrea, she can be 285, which is farther away, and 315, which is further away. He's more reliably close to 300 than she is. All right, who is more likely to hit the ball the farthest? Okay, well, let's go look and who will hit the ball? Who is more likely to hit it the furthest? Use evidence to support your answer. Well, the only evidence that we need is a standard deviation. Okay. If you look at Robert, his results are either 305 or 295, and 300 is in between there. Okay, so that's not very far. But Andrea, she can hit 315 yards. So who has a chance of hitting further? Well, if you look at the results, it is Andrea. And the reasoning is because she has a larger standard deviation. Okay, and then let's take a look at who will most likely hit it the shortest. Well, let's look at Robert. His one standard deviation is either 295 or 305. Andrea's one standard deviation is 285 to 315. So again, it's going to be Andrea because she has a larger